Alright, hello everyone. My name is Phillip George, and I'm going to talk about atmospheric impacts of expanded natural gas use. This was a webinar given by Dr. Dave Allen, or this is a presentation on a webinar given by Dr. Dave Allen. Dr. Dave Allen was the professor, he still is the professor of chemical engineering at UT Austin. He's written 6 books on urban air quality and over 200 articles. And he's a part of the Texas Air Quality Studies program, as well as almost every other air studies program in North Texas. First thing he talked about was energy. Energy is a huge thing in the U.S., and we are to be the top oil producer in the next 5 years, not just through oil. With this increased energy use, we need new methods to obtain it, and natural gas, for one, is very plentiful and is very easy to obtain through hydraulic fracking. And this is a video made by Dr. Allen and some of his colleagues on hydraulic fracking and how it works. And here we have the fracking site, and this is sedimentary rock, and this is the shale formation that they're going to be going into. So they're going to drill a vertical well, and then it's going to go horizontal into the shale formation, and they're going to fracture it with pressurized water mixed with several chemicals and sand as well. And that, through secondary porosity, is going to increase the porosity of the shale rock from about 2% to somewhere to 20 to 25%. So it greatly increases the porosity of it. They use a perforation gun after they drill it to make these little slits in the rock, and those can be about 100 feet tall in both directions. And then they pump water into it with friction-reducing chemicals so that it's not too hot and it doesn't injure the shale that much. And that can be done about 70 times across the horizontal well. Those horizontal wells can be as long as 1 kilometer, Dr. Allen says. And once the water is in there, they put a little cement type thing to make sure that those little perforations stay there, and they can act as entryways for natural gas or oil to enter. And once that's done, then natural gas will enter through those and go up into a storage tank. And those storage tanks can be utilized, or not the storage tanks, but those these wells can be utilized for up to 10 years. A little less than that in most cases. Hydraulic fracking is done with shale rock, which has a very low porosity. Some of the pores are as low as 1.1 nanometers. This creates venues for natural gas to flow through, and sites can be used up to 10 years. This is a map of the shale plays in North America. Shale plays are geological areas where a large amount of natural gas can be found. We talked about it earlier today, but the Marcellus shale play up in the corner goes through Pennsylvania. Is the place where oil was first found in the United States. But that's the largest one in the U.S., and that holds about 180 trillion standard cubic feet of natural gas. But this presentation was mostly done on the Barnett Shale in North Texas and the Eagle Ford Shale in Lower Texas, where UT Austin is, and where Dr. Allen is. Here's a picture of the global shale basins. Right now, the U.S. is about the only area that has estimated all of their shale basins, along with Argentina. We have the second largest, and this is in trillions of cubic meters. I believe Dr. Allen said that this is the amount that can be taken with our current technology per year. And natural gas is a very valuable thing for us right now because per million BTUs, it's very cheap. The only thing cheaper that he talked about was coal. And if we could wean off of oil a bit, natural gas would be a great alternative. Here is the natural gas prices for the United States. Texas is generally a little bit lower. That's because they have a lot of shale plays to work with to harvest natural gas. A good portion of Texas's electric power comes from natural gas itself, as we were about to see here. In 1997, it was almost all vertical wells, but once they realized, scientists in the area realized that a large amount of natural gas could be found around 2005, when prices were a little low, the horizontal wells started popping up almost everywhere in the Fort Worth area. Wet gas is a big reason why natural gas is being used a lot today. Wet gas is gas that is harvested along with oil. So when oil is being produced in the United States, they're also getting a lot of natural gas with it. Makes it a lot more economically viable. And there's 5 plays in the United States that have this ability. The largest one being the one in South Texas, which is Eagle Ford. And this is their drilling and production from 2006 to 2010. This area on the top is just oil. In the middle is where you can find wet gas or oil and natural gas. And this bottom part is dry gas or just natural gas. And most of the drilling is being done in the middle region. Almost all of the large wells being drilled are in that area. The price changes for natural gas. If we switch from mostly oil and mostly coal to natural gas, we could see a dramatic decrease in price for electricity generation. Texas is showing a lot of signs of this, says Dr. Allen, with their 2 large shale plays. In agriculture, through the creation of ammonium fertilizers, as we learned about today, how natural gas can help make those. In chemical manufacturing, we make a lot of petrochemicals in the United States, and we could switch those to NGL chemicals or natural gas liquid chemicals. And in transportation, there's a lot of commercials going around the United States right now that are displaying San Francisco as using a lot of buses and trains that use entirely natural gas, and trying to pump up the natural gas industry. But what are the environmental impacts? Dr. Allen is only speaking in this webinar of the air quality environmental impacts, not of the ground quality environmental impacts that we hear about a lot when hydraulic fracking is talked about. This is how much water is used per well for drilling and hydraulic fracturing. This is an average. It changes a lot per shale play. But talking about the Barnett and the Eagle Ford, about 5 million for each well. And that's average freshwater used in gallons. And that's just freshwater. They use a lot of chemicals as well and a lot of sand. That's a slurry that they use. So each well produces about 28 trillion standard cubic feet of natural gas per year. There's 500,000 gas wells in the U.S. A lot of those are in Texas right now and in Pennsylvania. There's some in Chattanooga or some in our area, but not as heavily as there. And for 5 million gallons of water per well, that's 10 more times than an oil well would be using for fresh water, but it's a lot less than a gas or a coal power plant would be using for about the same amount of BTUs. So for natural gas, we have 100,000 BTUs per gallon of water. Some air pollutants from shale gas production. We have ozone and particulate matter. It's a lot less than oil. However, air toxics such as benzene chlorinated organics, as Dr. Allen said, a lot less than oil as well, and greenhouse gases, also less than oil. Some emission estimations that he's been trying to make along with his colleagues, they're very difficult to estimate because there's not a standard way or a standard machinery being used for each well. So each well is giving off a different amount of emissions. And the operation practices change very frequently. The nature of gas extracted, it's not the same zoo of chemicals every time, or same zoo of gases coming out every time, and the temperature also affects it. Here is the Fort Worth area. This is source emissions in tons per year around that region, and this is in the Barnett Shale. Each of these dots are wells, and he never said what EML was, but it's a green triangle pretty close to Fort Worth. We can estimate that. Above that are the largest source emissions in tons per year. So with that data, he calculated the average diurnal hydrocarbon concentration per day of that region, of the circled region, from April to December a few years back. Pretty standard. Early in the day you have a large amount of hydrocarbons, and later in the day they die off. Of the air monitoring that he and his colleagues did in North Texas, they did mobile ground monitoring. He never really explained how that was done. That's what he expanded most on. He said that he took a column of air and processed it, but when he explained the process that he used, he kind of mumbled it, so I'm not sure what the name of that process is. But they also used aircraft, satellite monitoring, and a dense fixed ground measurement network in field dates. When they took mobile ground monitoring, they used Google Maps, and this is of methane concentrations. And so they took a car with their mobile ground monitoring information on there and drove around the area. I believe he said this is Fort Worth. But in these spikes, this is the area where wells are, and this one on the side is one of the largest wells in the area. And this is just of methane. This is not of any other gases. This is just a chart of that same map, but of a larger scale. This is of the entire Fort Worth area. The maximum value of CH4 measurements in the background that they obtained was 7.79 parts per million, which is fairly high. So what they found through their monitoring is that a small number of sites, like the very large one that we saw on the right side of the screen here and over there, they dominate the emissions. There's only a few that are having fugitive emissions. The VOCs are well characterized. With natural gas, you can pretty easily determine what's coming out. And he said, Dr. Allen said, that direct emissions from shale gas production are not the dominant effect. But work is still ongoing. Of the Texas energy production, this is from ERCOT, or the Energy Reliability Council of Texas. This is what ERCOT can produce energy-wise on the left side, and what they actually are producing energy-wise on the right side. Natural gas is a large portion of it, but since coal is so cheap, they're relying very heavily on coal still. and coal affects air quality a lot more than natural gas does. So Dr. Allen's trying to persuade ERCOT to wean off of that. And their energy choices do matter. This is another image from ERCOT on different amounts of gases or toxics that are coming out from each energy process along with water. SO2 from coal compared to natural gas on average is incredibly in favor of natural gas. And natural gas does have lower emissions of nitrous oxides and CO2. This is the average ozone impacts. Dr. Allen talked of this. As the prices for natural gas went down, right here we have 1.89. That's per million BTUs, and 2.88. Those are dollars, US dollars. The ozone emissions in the area are down very heavily as opposed to when natural gas prices were very high, over on the right side at $7.74. So once natural gas prices went down, the ozone emissions went down because ERCOT was using a lot more natural gas and a lot less coal. To summarize what Dr. Allen was talking about, shale gas can transform the global energy landscape, and a lot of areas in the world have large shale plays to work with, or that are very close by to work with. Shale gas production impacts much more than electricity, along with agriculture and transportation. Natural gas can be used in a lot of different ways. U.S. is pioneering shale gas production methods, but we're still working on ours to help other developing nations have very reliable sources of energy. And we need to understand